Hello world, today we're going to talk about pure functions. What are they and why you might want to start caring about them? Disclaimer, the term function has lost precision in the world of computer science, which should be evident given the fact that we're using adjectives to further classify them into pure and impure, so I might be using the term for blocks of code that wouldn't really qualify as one. So what makes a function pure? It is deterministic, and it has no side effects. To be deterministic is to produce the same output given the same input. Given a purple circle, the function always produces a red rounded square. No matter in what case you give the function a purple circle, a red rounded square is what you get in return. A peach circle results in a blue rounded square. A purple circle in a red rounded square. Always. To have no side effects is to have no observable effects. Printing to a screen, writing to a database, sending packets over a network, logging, mutation are all examples of side effects. They can be observed. A user can observe when a function prints something on a screen. A dev looking at a log file can observe when a function logs something into the file. A function accessing a global variable can observe when another function modifies the global variable. A process reading a database can observe when a function writes into the database. Basically, anything that makes a program useful is a side effect. You want to be able to draw stuff on screen, send out emails, write stuff into a file. All useful things that you would want your program to do are side effects, and pure functions can't do any of them. Pure functions are useless, pretty much useless, on their own. Then why bother? Because impure functions can be painful to understand, hard to test, taxing to debug, daunting to parallelize. Let's look at a couple of functions that can be hard to test. Greet takes a string, a name, and returns a string, the greeting. Is this pure? No. Why? It's non-deterministic. You pass the same name, you won't always get the same greeting. Run greet Mac in the morning, it's good morning Mac. But run it in the evening, it's good evening Mac. How are you going to test this? Run it in the evening and expect good evening in the return value? Run it in the afternoon and expect good afternoon? Or mess with the system clock before running tests? That's definitely cumbersome. What is the origin of this non-deterministic behavior? The call that's reading the system clock. The function's output depends on this input, but is not provided by the caller. Print grade takes a number, the mark scored, and prints the associated grade. Definitely not pure because of the side effect of printing. I remember writing this at a time when I had no notion of writing tests. The program would read input from the command line and write the output back. The only kind of testing at the time was feeding the input and carefully looking at the output. But how would we write tests for this? The tests should run print grade and read the standard out and do a string comparison? It's objectively finicky to test. Around the same time, when I was doing the manual visual testing, I remember spending a significant amount of time looking at linked lists I was printing and trying to figure out why my insert function wasn't working properly, only to realize that there was nothing wrong with it, but it was my print function that had a problem. Let's purify these and see how it aids testing. For greet, we'll write a function that explicitly takes a number of hours to pass as an argument. Writing tests for this is as easy as doing asserts. No fiddling with the system time or when the tests are run. But yes, someone will still need to read the system time. Greet will just read system time and call the pure function. There is nothing in this new greet that needs testing. For print grade, we'll write a function that returns a character, the grade. Tests for this become trivial. Asserts can do the trick, and print grade just calls the pure function and prints the character returned by it, leaving nothing of importance untested. Note that we're not eliminating side effects, because as established earlier, they are absolutely necessary if we want our program to be useful. Let's look at another function, dump char frequencies. Takes a string that paths to a file and prints the character frequencies found in the file content. This is both non-deterministic and side-effecting. Call it with script.md at different times, you'll see a different result if the file is modified between the calls. The cause of non-determinism is that it depends on stuff outside what's given as input. The path is input, but the real thing it depends on is the contents of the file. If something were to misbehave around this, it could either be the function itself or that the contents of the file were not what you expected. It can be taxing to investigate. Functions become non-deterministic when they depend on data from sources that are not explicitly passed by the caller. The contents of the file in case of dump char freaks, the system time in greet. Other instances include depending on a global variable, a row in a database, a reference. When a function depends on anything that can be modified by external entities, it loses purity to non-determinism. And when a function itself modifies an external entity, like a file, a database, or a global variable, it loses purity to side effects. Essentially, a function becomes impure when it interacts with anything other than the values passed in as inputs. With impurity comes insanity, calling the same thing over and over and expecting different results. Impure functions are coupled with time, not discrete, which is quite literally dependent on time. It matters when you call those impure functions. Changing the order of impure calls can disastrously affect a program's behavior. A read followed by a delete is very different from a delete followed by a read. It also matters how many times you call an impure function, while pure functions are idempotent by nature. You can call them as many times as you want, and they won't do anything other than return a value. You can't freely call a function that is responsible for sending out payments as many times as you want without consequences. Impure functions can be affected by things that are totally unrelated to or completely out of control of the caller, like some file getting modified on the system or the passage of time. But with pure functions, you don't have to worry as much. You only ever need to care about the inputs that were given to it, because those are the only things that influence the behavior of the function and the body of the function itself. That's a whole lot lesser to worry about. As we saw, the way to combat the insanity of impure functions is by increasing purity. Let's revisit dumb char freaks. To purify this, we would write a function that would take the file content and return a struct representing the character frequencies. And then we would somehow print that struct. This function is in good shape. Reads data from outside the input, followed by pure computation, followed by an output side effect. Programs should be structured like sandwiches. The bread is non-deterministic and side effecty, and the filling is pure. And a good sandwich has more filling than bread. Writing a program with a lot of pure functions is like writing a script before starting the voiceover. If I were to do the voiceover without a script, making changes would not be impossible, but definitely more difficult than editing simple text and recording after all the editing of text has been completed. That's all for this one. I know I did not list down all the advantages you get with pure functions, but maybe I'll talk more about them in a later video. Thanks for watching. If you like this, hit the like, share, and or subscribe buttons. The only reason I said that was to trigger the micro interactions on the buttons.